Good morning, everybody. Thank you for joining my session today. Let me start with some questions. How many of you are using Cassandra for consumer-facing applications? Okay. How many of you are using Cassandra for infrastructure or administration tools? How many of you are using Cassandra for operational enterprise software for business people? Well, pretty good group of people, but usually enterprise software is not common application for Cassandra, which traditionally relies more on relational databases. But at Reltio, we use Cassandra to build very powerful data-driven applications. And in this session, I'll tell you why. What do we mean by data-driven applications? For our customers, this means to be right faster. Be right faster with reliable data, relevant insights, and recommended actions. You can't be right if your data is wrong. Garbage in, garbage out. It is impossible to have relevant insights if you're not factoring all huge amount of information that builds complete picture. And recommended actions come with learning of data behavior, users' behavior, data patterns. In other words, applying machine learning. In this session, I'll be focusing on the first part of Reltio equation, reliable data, as this is the one where Cassandra plays a major role. But first, let me start with some introductions. My name is Anastasia Zamyshlyaeva, and I'm VP Platform Product Management at Reltio, and I'm co-founder. We started the company in 2011, and today we're over 100 people. We started the company upon belief that organizations need reliable and relevant data at their fingertips. 4 years ago, I started to play with Cassandra to see what will be the best persistence layer for our hybrid columnar and graph data store. And out of various options, I've chosen Cassandra. We're using Cassandra in production since 2012, and because of this, we were able to achieve 24/7 uptime with 99.995% availability. We use the same cluster and the same hardware to support various customers in the same multi-tenant environment. And the same data store is used both for operational and analytical workloads. If you focus on the smallest details, you never get the big picture right. Like in this picture. When I show you the first fragment, you can try to guess what it is. You can even make some decisions on top of this. Then when I show you the next fragment of this data, the direction of your thoughts can go in completely different direction. But the truth is that reality could be completely different. And this is what is happening within the enterprise. They have all this data, but business people are making decisions having just smaller picture in front of them. They're limited to the application they're using. Let's dive into this with more details with a company that most of you are familiar with. This is an enterprise company from the Office TV show, Dunder Mifflin. For those who do not know, they sell paper and office supplies. As an enterprise company, they have sales department, which goal is to find customers and sign up contracts to supply paper. All clients of Dunder Mifflin have an access to a website where they can manage information about their account, where they can change how frequently do I want to receive supplies. To be effective with supplies, Dunder Mifflin bought an application for supply team that allows effectively deliver paper across various customers in different regions. Of course, they have marketing department, they have support, a lot of other departments. So in this picture, just 5 of them. 5 departments, 5 different applications that perfectly addresses needs of each department. But these 5 applications have their own database with each own data store. That's why all the data is isolated and kept in silos. But at the same time, information about the same object could be stored in various places. So for example, on company website, there could be information about John Smith, the customer, that he's maintaining. There could be information in sales department, in supply, like everywhere across enterprise, information about the same account that shows data from different perspective. And data can be updated in one place, but other applications will have no idea about it. And to bridge this gap, IT team comes into play. They're asked to synchronize data from one application to another. So for example, if sales team sign up contract, they want to automatically create an account on website. If sales team sign a contract, they want to automatically start supplies. And I can just continue drawing these arrows between each application into each application to try to have this bigger picture. Actually, companies are spending huge budgets on this kind of activity and a lot of time. They're trying to introduce queues, so to listen what is happening in one system. And when something has happened there, they're taking this data, transforming data in the format that that application understands, send it, and save it. And at the same time, what if that application is not available? What if this connector dies? Like a lot of things that IT team needs to consider to have this big picture. And this all adds complexity to overall infrastructure. This is actually a real diagram of such enterprise system. You can see a lot of applications with their own databases. And there is synchronization between various applications. And synchronization can be done with special tools that companies are buying that focuses on bringing data from one place into another. It could be some home-baked tools when IT team is developing something to do synchronization. Or it could be some old-school approaches, such as, hey, Mike, this is Dwight. Do you have information about John Smith? Uh-huh. Can you spell it? Like, yeah, really, this is what is happening with an enterprise. And after this, the logical question is data up to date? Another logical question is data correct? So what if one application provided incorrect data? Then this is just spread across all enterprise, and all enterprise now have incorrect information. How to roll it back? How to understand what's the current state of the object should be? The other logical question, is data complete? Every application is limited to its data structure. Of course, there's some flexibility to extend this schema, but the question is, how far can you extend this schema? Or the question is, what should be that application that stores bigger picture? Should it be sales application that have information about support tickets? Or like too many questions. To address this problem, 15 years ago, a new type of application appeared to unify data from multiple sources. Often, they're called as master data management. Their goal is to consolidate data from multiple sources, bring together, address any conflicts, blend it, and provide a unified view of data across enterprise. As this application appeared 15 years ago, traditionally, they are based on relational databases with certain problems that relational databases have, such as fixed structure. What if you have new attribution that you want to bring? Then you need to do alter table that locks database. Not cool. It's close to impossible to bring big data. For example, think how will you bring information about all emails across enterprise, about click streams of clients on the website? Almost impossible because hardware is crazy expensive for such systems. It is hard to support structures such as graphs or complex attributes because this requires additional tables, additional joins that doesn't affect grade or overall performance. And usually they have single point of failure that can be worked around, but again, a lot of problems. So after that, enterprise start getting bigger picture, but still fragmented because some of information can't be brought into this big picture. At Reltio, our goal from the very beginning was that we want to bring all data, no matter how big it is, no matter how complex its structure. We wanted to support structures such as entities, relationships, graphs, interactions, historical data. And for this, we have chosen Cassandra. On the one side, Cassandra doesn't have very powerful data model that we would benefit from. Or it doesn't have other blinks, such as powerful query language or bulk operations. But it does what it promised. It has high performance, fault tolerance, linear scalability, multi-data center availability, so all the things that you hear a lot on this conference. And we use a commodity hardware. That's why we've chosen Cassandra as our primary data store. At the same time, our use case is not typical for Cassandra. First, this is enterprise. Second, Reltio platform is foundation to build data-driven applications. According to DataStack's recommendation, you need to think, how do you want to use data? How do you want to expose this to UI? What queries do you want to make? And this will drive modeling piece. In our case, in case of platform, we have no idea with what objects we'll be working with. Will it be organizations, individuals, products, or maybe it will be database of cats and dogs? Like anything could be there. So for example, in our cloud, we can have a tenant where somebody defined schema for doctors and hospitals. And this automatically will drive all the UIs, all REST APIs and analytics for life sciences or healthcare schema. Reltio will do all the cleanup of the data, merging data to have accurate view across enterprise. So here on the left side, you can see various UIs that were generated automatically out of metadata that helps to maintain doctors, hospitals, affiliations, hierarchies, historical data. And we provide insights and recommended actions for sales or marketing team in this UIs. Or another scenario, the same cloud, just different configuration, where we have configuration for oil wells and other equipment. And with this application, we are targeting a completely different set of users. These are users who are interested in having 360 view of oil and gas production across hundreds of wells, hundreds of thousands of wells worldwide or in the country. Another application and another metadata that drives all UIs and APIs. Somebody wants to manage asset catalog for movies, for songs, for TV shows, and blend all this information with social media. So for example, have some sentiment analysis on top of various movies. And this is different application. This is one Reltio cloud for 3 different use cases that resides in the same hardware and targets completely different use cases and different users. In your Reltio tenant, you can store entities, organizations, individuals. You can store relationships, such as John's spousal relationship. You can store information about graph, John's social graph, transactions, how John went to the website and what links he clicked, so maybe to predict what he's interested in. We store historical information, and Cassandra for this is foundation. In the remaining session, let me focus on what challenges did we have using Cassandra while building Reltio. So the first challenge that we had was modeling complex documents. And the additional complexity that we have on Reltio's side is that every attribute, even simple string, it can come from multiple sources. That's why we need to support multi-valued attributes for everything. Because sources, different systems can't agree on having certain value. And additional complexity is that we want to support very complex structures. And again, these complex structures can come from multiple sources. So let's take an example. We want to build an application that maintains individuals with emails, addresses, names, and this is kind of business object that our users are configuring. So there's no need for them to go and understand Cassandra and all underlying structures. They just said, we want to work with individuals with that structure, and we drive everything by ourselves. So as an example, we have John's profile with 2 emails and 2 addresses. And let's see how do we use Cassandra to build this. We use one column family to store entities. And in this example, I'll be using thrift terminology. We use one column family for all entities. One row is representing one complex document. One value for simple attributes goes into one column. Column of a name is metadata driven. So like in this case, name.1. And then value goes into cell. Here you can see that even for simple attributes, we have index. And this is because data is coming from multiple sources. And simple attributes can have multiple values. Multi-valued attributes, very similar way as for simple. So each value goes into separate column. Column is metadata driven and unique, and value goes into cell. This approach allows us update each element independently of each other. So we can just update email 1 without touching data that is stored in email 2. All right, let's go into a more complex scenario where we have nested attributes. In this case, it is very important not to mix data from multiple nests. For example, we don't want to say that California is billing address and New York is shipping. We really need to preserve this values. That's why every attribute is having its own ID. Like California shipping is 1, and New York billing is 2. And then for nested elements, such as state or type, we also introduce IDs because data can come from multiple sources. And here, this is how we model nested structures. What it gives us? We can build nested structures of any depth. We can have any number of attributes on each level. And we can update each element independently. Cassandra allows us to persist and replicate data across our data center. It allows us, with this kind of model, to have atomic updates on every element. And at the same time, we can do transactional update on the whole document. We can retrieve just some of the attributes. So for example, in this query, I'm interested only in addresses. And we can do with such model. We can support thousands of attributes that have a lot of values each. And we, with such model, can store only those attributes that have actual data. So this saves us disk space. Reltio platform will take care of transforming this kind of structure into documents, and will address any conflicts that you have in data. So this is the smart logic that Reltio will put on top of this. This, as you mentioned, this is thrift terms, right? And this is how we started. And we were quite happy with thrift. And then according to DataStack's recommendation, we should move to Cassandra Client, which uses CQL. So our first impression was that it's close to impossible to support our very complex structure that can have thousands of attributes, and each attribute can be multi-valued. We even did some experiments. We tried to model what we have right now with static schema, and as a result, our performance degraded. And then we start thinking, does CQL really means static, or can we continue having wide rows? And CQL does support wide rows. So this is definition of the same schema as I was talking before. We have column family for entities that have doc ID as partition key. We have attribute name and attribute value to model the same structure. And actually, we can continue making the same requests as we did before, for example, to retrieve just some of the information, such as addresses. So basically, everything that you could do with Thrift API, you can continue doing with CQL3. Another scenario that we use, where we use Cassandra. We use it for hybrid graphs. I already walked you through how we can model entities with infinite attributions. But having information about entities is not enough. It's not enough to know my name, right? And my email address to know who am I. It is important to know what relationships do I have, what strengths of these relationships. That's why relationships are very important. And we do support this through Cassandra. So here you can see various entities such as organizations, employees, products, and individuals, which can have infinite attribution. And we also can define in metadata relationships between these objects. So for example, I can say that Dwight is employee of Dunder Mifflin. John buys paper copy paper. And this is what you define in metadata. And this is what drives UI. This what drives all APIs. So from Cassandra, we use basic foundation to actually save our data. From Reltio's side, we have metadata-driven graphs with very rich model for entities and relationships with infinite attributions. And we do partitioning and effective joins to provide high-performance graph operations. Next use case where we use Cassandra, Reltio deduplication. Data can come from multiple sources, and if we not merge it together, then it will continue being in silos. You will have one data from one source, one data from another source, and it will be never linked together. So that's why it is very important to build effective deduplication mechanism. And to have high performance, high quality dedupe mechanism without users' intervention, it is important to factor all information. So like in this example, I have two John Smiths with slightly different names. So potentially this could be two same entities. But we can't guarantee. And if we start making decisions just on top of attributes, we can go into too many false merges. Then after this, data stewards need to go and unmerge and understand. It's pretty non-convenient. But what if we have additional information that we will start factoring? For example, we have information about their addresses. And we know that they live within 2 miles radius. So this really increases chances of these two records being the same. What if I tell you that John Smith without H and John Smith, they have the same daughter, Stephanie? Then all this information really increases the probability of these records being the same, close to 100%. So it's very important to factor all information to build effective deduplication mechanism. We use only Cassandra to support this. We have additional column families for this, and the types of matches that we do support just using Cassandra is matching by attributes, both fuzzy and exact is in this example. Geo-matching and graph matching. For incremental matching, we use just Cassandra. But if you want to do very, very fast bulk matching across whole tenant, then we are using combination of Cassandra and Spark. One more interesting use case of Cassandra. Cassandra doesn't have a very powerful query language. It has some integrations, but it doesn't work perfectly well for us because we need to transform our complex metadata to certain structures. And for our use case, we found that Elasticsearch is better fit, and we do transformation by ourselves. So for search by Elasticsearch, perfectly fine. And then we started to explore, how can we use our cluster more efficiently? What if we exclude document contents from Elasticsearch and use it only for indexing and returning IDs of objects? And then we use Cassandra to retrieve whole information. So this is what we called hybrid search. And we've got some very interesting results. So the first result, predictable, that the size of Elasticsearch index reduced twice. We already have this information in Cassandra. That's why we reduce this and the cost to our cluster with zero loss of functionality. Second area is that Elasticsearch indexing performance also increased twice. And that means that we can use the same Elasticsearch cluster longer without need to scale up. This is something that we didn't expect. If we did search on large documents, then hybrid search sometimes provided performance 20 times faster than just pure Elasticsearch. So at Reltio, we have a lot of interesting scenarios and use cases. We continue collecting data from multiple sources, blend it together, cleanse it with data providers, with cleanse mechanism, with enrichment from social media. We do manage relationships, entities, graphs. We do analytics on top of this. And we do insights and recommended actions. And for all of this, we are using Cassandra as our primary data store. Apart from Cassandra, we are heavily using Elasticsearch for indexing. We use Spark for analytics, such as segmentation, clustering, ranking. We use Elasticsearch. We use Spark for machine learning, for bulk operations, and then with Spark, we are able to bring this data back to Cassandra. And for SQL interfaces that are very often used in enterprise world, we use Redshift, Amazon Redshift. Reltio allows to simplify a lot of architecture, removing a lot of complex and moving blocks. We can provide a single place where you can bring all the data and have insights and recommended actions on top of your data. So if you want to learn more about Reltio use cases, please stop by our booth. Thank you. Questions? Graph technologies. So we built our own graph technology because we needed that control to maintain merging of graphs, to understand what information came from what sources. So we started build a graph foundation for our solution 4 years ago. So this is pretty much the same when Titan appeared. Titan is good tool for managing graphs, good database. We have some extended scenarios where we can't use TitanDB, and that's why we need to continue maintaining our graph data store and graph database.
So as the individual departments do cleanup of data, how is that synchronized with the Cassandra where you keep all the metadata?
So this is synchronized with through connectors through our REST APIs that are metadata driven. And as we use Cassandra and all our other foundational pieces that you see, they're highly available. That's why Reltio is always available, and there are no problems with hey, Reltio is not available. What should we do with synchronization? I think there was the question.
I have a question about the oil and gas side you mentioned. What is the application area are you using? Is it in the exploration? Is it in the well logs? Is it looking what the production is?
So this is.
And what technology do you use?
So this is we are using for tracking information where all wells are located. We are tracking information from each well, from various equipments like Internet of Things, of what is happening within each well. So also you can on a map you can try to find where there are possible places for wells. You can try to predict on all the data that you have where there could be potential breaks on wells equipment. So you can bring any information. What you track, you can bring everything into Reltio and use it to have more powerful insights.
What do you do to keep the Cassandra and Elasticsearch in sync? Presumably, if you search for a document, it has to then also exist in Cassandra and vice versa.
We're using our internal tool. We wrote our own code that understands metadata and understands this structure and does synchronization.
You mentioned the connectors. Do you use special ELT connectors or database connectors? So what type of connectors do you use?
Special?
Connectors, do you use Informatica? Do you use Oracle Data Integrator to connect to Oracle or to SQL Server? How do you connect to those databases?
How do we bring data inside Reltio?
Well, if you're doing a bidirectional synchronization,
Yes.
How do you maintain the updates on the source system?
So there are various tools that help to do synchronization, such as SnapLogic, MuleSoft, or Informatica. So what we did, we created our plugins into those systems, so you can use Reltio as target and as a source.
So you don't have a direct connection to the actual source databases?
No, this is not our business.
If Elasticsearch might go down in a data center, do you ever find yourself having to re-index? And I'm wondering, now that DSC has its search capability, how, if you'd reconsider that and how you would compare your solution?
We didn't have a lot of cases when Elasticsearch went down because this is also a distributed, highly available component. So if this happens, then this is considered downtime on our side, and we have all the mechanism to repair data from the moment when something happened. So we can repair all the information on Elasticsearch when it is up again. If you compare this,
it's sort of like an incremental re-indexing?
we can do incremental re-indexing. Another area was the comparison with DSC, right, and with search that we have out of DSC. So the problem is in complexity of our data structure. If you just put all the information that I showed you that is in column families, if you put this directly in Solr, it just doesn't make sense. You need to combine this. You need to do some transformation. Plus, also, we bring data from multiple column families in one search document, which is not supported by DSC. This is just some very specific use case on our side. But if you have all the data that you have inside column family that you want to be available in search index, DSC is perfect solution for that.
Any other questions? All right, well, thank you very much.
Thank you.